permanent movement of shared pair of electron towards the more electronegative atom, we call it as what? Inductive effect. What does mean by conjugated system? Conjugated system in the sense the double bond, then single bond, then double bond, like that it will be present in the order. This positive inductive effect we can observe only when electron donating group if it is there in the carbon chain. Hello my dear students, a warm welcome you all. Myself is Purnima, lecturer in Department of Chemistry at Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. My dear students, in our last discussion, we were dealing with the unit called Organic Chemistry, some basic principles and techniques. Today, let us recall what we have understood in our last session. So, in our last session, we have understood about the isomerism and its type. So, all of us, we come to know that isomerisms or isomers are nothing but two or more compounds having the same molecular formula but difference in their physical and chemical property. We call it as what? Isomers, and the phenomena which is known as isomerism. So, we can classify these isomers into mainly two types. One is structural and the one is stereo. Again, in the structural, there are four types will be there. We have understood in detail with an example. Today, let us move on to the, in addition to this, we also understood about the fundamental concepts in the organic reaction mechanism. In that, we have understood that what are the cleavages will be there when the reactant undergo reaction, that is homolytic and heterolytic cleavage. In addition to that, we also understood about the types of attacking reagent. Today, let us move on to the next topic of this unit by understanding the electron displacement effect in the covalent bond. In that, mainly we have a four effect. First one is inductive effect. The second one is mesomeric effect, or it's a resonance effect. The third one is electromeric effect, and the last one is hyperconjugation. So, first we will understand what is mean by electronic displacement in the covalent bond. As we all know that in organic chemistry, it mainly deals with the carbon and its hydrogen, correct? And we all know that the carbon has a 4 valency. During the reaction, you know what happened? The carbon will share all its 4 electrons, thereby it forms a 4 covalent bond. Okay. The reactant, if it is there, okay, during the reaction, that electrons in the reactant will be involved in the partially or completely displacement. The electron will involve in the partial or the complete displacement. This displacement of the electron in the reactant during the reaction, we call it as what? Electronic displacement in organic molecules. Okay. So, let us understand what role the effects will be there. Okay. Mainly, we have 4 main effects. First one is the inductive effect. Let us understand what is mean by inductive effect. You can see that I have considered the reactant here in such a way that this is my methyl group and this is my one of the electronegative element. Now, if you see that the electronegativity differences between the carbon and the chlorine will be different, correct? And we know that the chlorine is more electronegative. Since it is more electronegative, the shared pair of electrons, the shared pair of electron in the sense the carbon and chlorine, they are sharing one electron. That will attract it towards the chlorine only. As a result of this, the carbon which gets a partial positive charge and the chlorine will get the partial negative charge. So that once there is a partial positive and a partial negative charge, there is a permanent displacement of the shared pair of electron towards more electronegative atom will be taken place. This movement of or this permanent movement of shared pair of electron towards the more electronegative atom, we call it as what? Inductive effect. As a result of that, you can see that the carbon will get a partial positive charge and the chlorine will get a partial negative charge. And this effect which is known as what? Inductive effect. Okay. So we'll recall it once again. Okay, it is a permanent displacement of shared pair of electron along the carbon chain due to the presence of the atom of the group of atom with a different electronegativity. Okay, so either one group will be there or many groups will be there. Okay, if there is a difference in electronegativity, the shared pair of electrons will attract towards a more electronegative atom. So which is attached to the carbon atom. This is known as what? Also known as permanent effect. This is also known as what? Permanent effect. Why it is permanent effect? Because the shared pair of electrons are completely moved towards the more electronegative atom. And these inductive effects are of two types. One is positive inductive effect, another one is negative inductive effect. So let us understand what is mean by negative inductive effect. If the carbon atom attached to the higher electronegative atoms like a chlorine, the shared pair of electron is attached towards a more electronegative atom. So this is known as what? Negative inductive effect. Ma'am, when does it takes place? Remember, this negative inductive effect will take place only when electron withdrawing groups are there. When electron withdrawing groups is there, obviously, that electron will be withdrawal from that groups and thereby it forms a negative inductive effect. So we can see this effect in the halogen groups also, and it should be in the order also. I'll write the order so that you will understand how does that entire order will looks. First one is NO2, okay, which is more electronegative than Cn, then SO3H, then aldehyde, then ketone, then we have fluorine, chlorine, bromine, iodine, and even alkene also, okay, then benzene ring. So these are the electron. What are these? These are electron withdrawing groups. If this group is there in the carbon chain, it can easily draw the electron towards them because it will attract the electron. Thereby polarity will be developed. Once the polarity which is developed means the partial positive and a partial negative charge will takes place. Okay. So the negative inductive effect will take place only when the electron withdrawing group, if it is there in the carbon chain. Let us understand the same order which I have written. You can see that NO2Cn, COOH, COR, fluorine, chlorine, bromine, iodine, OH, OCH3 and C6H5 even with the hydrogen also. Let us come to the positive inductive effect now. This positive inductive effect we can observe only when electron donating group if it is there in the carbon chain. If electron donating group if it is there in the carbon chain, it will move the shared pair of electron towards the carbon only. We will understand that by taking with an example. Okay. CH3, CH2, CH2, C, CH3, CH3 and CH3. You can see that this is my electron donating group, correct? So these are electron donating groups. If the group is there in the carbon chain, what it will do? We know that this carbon is sharing one electron, thereby it forming a single covalent bond. During the reaction, what will happen? The shared pair of electrons will be more attracted towards the next carbon atom, towards the carbon, the next one. Okay. So this is known as the positive inductive effect. This positive inductive effects can be observed only when the electron donating group, if it is there. And you can see that how does that order will be there. So this is tertiary, then secondary, then with a primary. Okay. So this is how we can understand if electron withdrawing group is there or if electron donating group is there, how does the carbon atom base a partial positive charge or a partial negative charge, which tells about the inductive effect. Hope you all understood with this. And We can also make a note about the inductive effect. Suppose if the more electron negative group is there, or more electronegative atom if it is attached in the carbon chain, we can see that inductive effect up to the 3 carbon atom. I can write with an example so that you can understand. CH3, CH2, CH2 and Cl, and you can write one more carbon. Okay, so this is my carbon chain which is having a more electronegative atom. Since it is more electronegative, it attracts the shade pair of electron towards itself, so thereby the carbon will get the partial positive charge and this chlorine will get the partial negative charge. This inductive effect can be observed, or it will affect the other carbon atom also. So up to the 3 carbon atom, okay, up to 3 carbon atom, we can see the inductive effect. Next is resonance or mesomeric effect. We all know that resonance effect, it is nothing but it is a delocalization of the pi electron. So we already understood in the chemical bonding unit, correct? So let us note about the resonance effect as well as with their types. Okay, resonance effect is a polarity which is produced in a molecule by the interaction of 2 pi bonds or between the pi bond and lone pair of electron present on the adjacent carbon. So we can easily modify this definition and we can say that resonance, it is nothing but delocalization of the pi electron. Why it is get delocalized? Because if pi electron is there in a carbon chain or in the benzene ring, it is not having a particular place. It will get delocalized. So this delocalization of the pi electron, which we call it as what? Resonance. Okay. The effect is transmitted through the chain. The presence of the alternating single and double bonds in an open chain or in the cyclic system is termed as a conjugated system. Suppose if you see the resonance effect, one of the condition is necessary. So this resonance effect can be observed only when the compound which is having a unsaturation. Unsaturation in the sense, it may be a double bond or it may be a triple bond. That must be there. And one thing is, we need to have a conjugated system. What does mean by conjugated system? Conjugated system in the sense, the double bond, then single bond, then double bond. Like that, it will be present in the order. I can show you with an example so that you will understand. Like CH2 double bond, CH, single bond, CH2, single bond, CH. You can see in this example, how does a conjugation system will be there? We have a double bond between the first 2 carbon atom, then we have a single bond, then it is not having a double bond. This is known as what? Conjugated system. Suppose if you are observing a resonance effect, that compound should have what? A double bond. So either double bond or triple bond, and it should have a conjugated system. So in such system, what will happen? The pi electrons will be started delocalizing. This delocalization of the pi electron in such compound, we call it as what? Resonance effect. And this resonance effects are of 2 types. One is negative resonance effect and another one is positive resonance effect, which in turn known as the plus R effect or plus M effect or minus R effect or minus M effect. We will understand in detail about the positive resonance effect or the positive mesomeric effect. In this effect, the transfer of electron is away from an atom or substrated group is attached to the conjugated system. So this electron displacement makes a certain position in the molecule of high electron densities. This effect in the aniline will be shown. You can see that this is the structure of the aniline, correct? So this is my benzene ring having a 3 alternative double bond and also have a NH2 group, and I call this compound as a aniline. So we can see this conjugated system in the above compound which is having a unsaturation, correct? In addition to this, we can see this unsaturation, or we can see that conjugated system where the group which is having a double bond or single bond or that special group that also carries the lone pair of electron. Okay, so that we call it as what? Conjugated system. So we always think that conjugated system in the sense there is an alternative double bond or single bond, but actually mean that it may also having the group which carries a single bond or double bond. Okay, in addition to this, it can also carries a lone pair of electrons, either it can also carries a single odd number of electrons, or it is a free radical. In the aniline, you can see that this is my aniline which is having a NH2. In that we know that nitrogen which is carrying a one lone pair of electron, correct? So if the such group is there, you know what will happen? The lone pair of electron move to this bond. As a result of this, you know, this pi bond will be shifted to this carbon atom. As a result of this, you know, you can see that the resonance hybrid which has been formed, where the nitrogens which is donating its lone pair of electron, hence it gets a positive charge, so that it will develop a double bond. Whereas this bond which is losing its bond, that is a pi electron which has been delocalized, so that this carbon atom gets a negative charge. Again, it is an unstable one. So it has to move towards to the next position, correct? So once it is moved, you know, again there is a shifting of the negative charge to the next carbon atom will be there, unless you can see that you will get a proper hybrid structure of the aniline. This process of obtaining the resonance hybrid from the resonance effect, we call it as what? Resonance, or a positive resonance effect. Okay, so finally you will get there is a complete shifting of a double bond, you can see that. So in the first example, you can see that the pi electron which is present on this position, so like this. But at the last hybrid, if you see that, you know, there is a displacement, or you can see that the pi bond which has been shifted themselves, correct? So this shows that this is how we are going to write the resonance hybrid if substituent group, if it's there, which is having a lone pair of electron. So we can see that positive resonance effect or the positive mesomeric effect can be observed with this group. First comes to the halogen, then with the OH, OR, OCOR, NH2, NHR, NR2 and NHCOR. Next we have negative resonance effect or the negative mesomeric effect. So the effect can be observed when the transfer of electron towards an atom or a substituent group attached to the conjugated system. For example, nitrobenzene. So you can see that in the nitrobenzene, the actual compound is NO2, correct? Okay. So in this NO2, you can see that the oxygen atom which is having a 3 sets of lone pair of electron. As a result of this, you know, the pi bond will be shifted to the next carbon atom which is having a double bond between the carbon and nitrogen. So it develops a double bond. So that the double bond between the nitrogen and oxygen, this is one of the pi bond, correct? So it is also get moved. Once it is moved, you know, what will happen? This carbon atom which gets a double bond, and this bond which is losing its double bond, hence it get the negative charge. And afterwards what will happen? Again it is a resonance hybrid. It is not stable. Another one of the pi bond will be shifted to the next carbon atom, so that the double bond will be created here. And again one more pi bond will be shifted to the next position, so that this carbon atom gets a negative charge. Thereby, you know, it creates the resonance hybrid like this. Again this resonance hybrid, if it is moved to this carbon atom, thereby it displaces. It will be moved to this carbon atom, it displaces a double bond to this next nitrogen atom. Thereby, you know, the negative charge will be removed, and you will write the resonance structure as a resonance structure like this. Okay, this is how, you know, negative resonance effect can also be observed. It is moved away from the substituent group or move towards the substituent group. Okay, the negative R effect can be observed in the groups such as carboxylic acid, aldehyde, ketone, cyano group, as well as with the NO2. Okay. Next, we have electromeric effect. So, after understanding with the resonance effect, it is necessary to understand what is meant by electromeric effect also. So, it is a temporary effect in which organic compounds which is having a multiple bond or a double bond or triple bond show this effect, and also this can be observed only when the compounds which is having unsaturation along with an attacking reagent only. If attacking reagent is there, if double bond or triple bond is there, in such organic compound only we can see the electromeric effect, and it is one of the temporary effect. How we can define this effect? You can see that it is defined as a complete transfer of shared pair of pi electron to one of the atom joined by the multiple bond on the demand of attacking reagent. So, there are strictly two types of electromeric effects will be there. One is plus and the one is minus. So, you can see that in the plus electromeric effect, I have considered the example of the alkane. So, where you have a unsaturation, that is a double bond we have. And since we know that in the electromeric effect, we should have what? Attacking reagent. So, what it will do? So, here the pi bond, it will shift towards the next carbon atom which is having sp2 hybridization, so that it will base, I can write it once again. So, this is my alkene where it is going to attack with one of the H plus ion, that is an attacking reagent. In the first step, what will happen? This attacking, this pi bond will be shifted to the next carbon atom. As a result of this, this carbon atom which is donating its shared pair of electron, hence it gets a positive charge, and next this carbon atom gets a negative charge. Like this it will looks, correct? So, now if the attacking reagent attacks for this carbon atom, to which carbon atom it will attack? So, this positive charge should attacks to the negatively charged carbon only. So, thereby it forms what? It forms what? It forms an alkene. So, it forms an alkane. So, this shows that there is a displacement of the pi electrons to the next carbon atom, thereby it gets the negative charge so that our attacking reagent can attack. So, this effect the pi electrons of the multiple bonds are transferred to the atoms in which the reagent attacks. Okay, we will see with the negative inductive effect also. In the negative electromeric effect, again I have considered an alkene, and also I have considered one of the attacking reagent, but here the attacking reagent which is negatively charged, correct? So, in the first step what will happen? First our reactant, it will shift its pi electron, correct? So, thereby it receives the positive charge and it receives the negative charge respectively, correct? Now, what will happen? Since it is receiving the positive and the negative charge, if the negatively charged attacking reagent is there, if the negatively charged attacking reagent is there, it should go and attacks to the positively charged carbon only. It will not go and attacks to this carbon atom which is having a negative charge. Why it will not attack? Because the negative charges will be repel with one another. So, it attacks to the next carbon atom which carries the negative charge. So, thereby, it forms what? It forms Cn here, then C, then this carbon atom which carries a negative charge. This is how the negative mesomeric effect can be observed when the attacking reagent which carries a negative charge, and here we can see that positive mesomeric effect can be observed when here it has to be carries the, here this carbon atom should carry the positive charge, correct? Yeah. So, this can be observed when the attacking reagent which carries the positive charge, that is a positive electromeric effect. In the negative electromeric effect can be observed when the attacking reagent which carries the negative charges. Next, we have hyperconjugation, which is a last electron displacement reaction in the organic molecule. So, this involves a conjugation system. It involves a conjugation between sigma electron with the pi electrons of the adjacent multiple bond or empty p orbital of the adjacent carbon atom. So what does it mean? In this hyperconjugation, the sigma electron, okay, the sigma bond will move towards the empty p orbital or the unhybridized p orbital, okay. So in this effect, the delocalization of the sigma electron of the carbon and hydrogen bond of an alkyl group is directly attached to an atom of unsaturated system or to an atom with the unshared p orbitals which is taken place. You can see that in the example of C2H5. I can write that C2H5 once again. This is CH3 double bond. C2H5, correct? So this is C2H5 which is carrying a positive charge. Here what will happen? This is a carbon which is sp3 hybridized and which is having a carbon and hydrogen bond, correct? So this sigma bond, okay, the carbon and hydrogen which carries a sigma bond will move towards the next carbon atom, or it will donate its electron to the next carbon atom which carries a positive charge, because this carbonate is not happy because it's having a very less number of electron to satisfied with the octet rule. That is why the sigma electron will donate, or the delocalization of this sigma bond towards the carbon which is having a sp2 hybridization and having a unpaired or unhybridized p orbital. Okay, unhybridized p orbital. You can see that this carbon atom sp2, in the sense there is a one unhybridized p orbital will be there. So this sigma bond will be give its electron to this p orbital which is unhybridized, thereby it creates an hyperconjugation. So this delocalization of the sigma bond towards the unhybridized p orbital we call it as what? Hyperconjugation. Again, this is a movement which takes place in a fraction of a second. Again, the electron will be come back to the original place. So it momentarily takes place, okay, not every time, or it not it's a permanent effect, or it will not share its electron, or that entire sigma bond will not move at all. It's a movement, okay, it's a momentarily which is taking place regularly, and again that electrons will be come back to the original state. Hence this effect are also known as no bond resonance effect. Larger the number of hyperconjugation structure, higher the delocalization of the pi electron and greater will be the stability of the compound. We can understand this with the stability of the carbocations also. In the next class, we are going to do with one of the interesting topics in the organic chemistry, that is nomenclature. So I'll wind up this class. I'll come back with the next nomenclature topic. Till then, take care, be safe. Thank you.